So we'll discuss multiple random variables. So in the previous case, what is that we have done? We have taken only two random variables, x and y. So what is omega is equal to x plus y, no? So whereas in this case, we take n random variables, n random variables, that is x1, x2, so on, xn random variables. Now what is y? Y will be sum of these n random variables, that is x1 plus x2 plus x3, so on, xn. Okay, then what is that probability density function of y will be equal to convolution of all individual functions, that is fy of y will be equal to what? Fx1 of x1 convolution, fx2 of x2 convolution, fx3 of x3 convolution, so on, fxn of xn convolution. Okay, so if your random variable y will be equal to sum of n random variables, then what is the probability density function of y will be equal to convolution of individual random variables. Okay, so this is the case for multiple random variables. Now we'll see the proof. So in this case, what we have done, we have taken three random variables, x1, x2, x3. Okay, we are taking three random variables. Now we are writing y2. y2 is equal to what? x1 plus x2 plus x3. Okay, then what is y1 ma? Say here we have x2 plus x3, no? x2 plus x3. This we are writing it as y1. So y1 is equal to x2 plus x3. So then what is y2 now? Y2 will be x1 plus y1. Okay, x2 plus x3 is what? Y1. No, we substitute in the place of x2 plus x3 y1. So what is y2 now? Y2 will be x1 plus y1. Okay, so now just now we have discussed from the definition of sum of two random variables. We know that, okay, here what is y2? Y2 will be sum of two random variables, x1 and y1. Okay, so what is the probability density function of y2 will be convolution of x1, density function of x1, and probability density function of y1. Okay, from the sum of two random variables, we are writing it as f y2 of y2 will be equal to what? F x1 of x1 convolution f y1 of y1. Okay, and we also know that what is y1 will be sum of x2 and x3. So what is probability density function of y1? Probability density function of y1 will be convolution of probability density function of x2 and x3. Okay, that is fx2 of x2 convolution fx3 of x3. Now we substitute fy1 of y1 in this equation. So substitute fy1 of y1 in this equation. So what you get? Fy2 of y2 will be equal to fx1 of x1 convolution fx2 of x2 convolution fx3 of x3. Okay, so what is y2? Y2 will be y1 plus y2 plus y3. Then probability density function of y2 will be equal to what? Convolution of probability density function of x1 and probability density function of x2 and probability density function of x3. Similarly, here now we consider four random variables. So y3, okay, sorry, y4, y3 can be written as what? Okay, y3 can be written as x1 plus x2 plus x3 plus x4. In this case, okay, just now we have discussed what is y2 ma? Y2 is what? x1 plus x2 plus x3, no? What is y2? x1 plus x2 plus x3. So what is y3 now? Y3 will be y2 plus x4. Y3 will be y2 plus x4. Now from the sum of two random variables, we know that the probability density function of y3, probability density function of y3 will be equal to what? The convolution of probability density function of y2 and x4. So fy2 fy2 of y2 convolution fx4 of x4. Okay, now now we obtained what is fy2 of y2. Fy2 of y2 is equal to what? Fx1 of x1 convolution fx2 of x2 convolution fx3 of x3. Okay, so fy3 of y3 will be equal to what? The convolution of individual probability density of individual random variables. So the probability density function of y3 will be equal to what? Convolution of probability density functions of individual random variables. Similarly, the same concept is expanded to n random variables. Here we are taking y is equal to x1 plus x2 plus so on xn. So we are extending this for n random variables. So in this case, what is fy of y? Probability density function fy of y is equal to what? It is the convolution of the probability density functions of individual random variables. That is fx1 of x1 convolution, fx2 of x2 convolution, fx3 of x3, so on fxn of xn. Okay. So from this what we can say, the density function of sum of n statistically independent random variables is equal to what? The convolution of their individual density function.